Okay, so function calls without recursion. So let's say, for instance, we have a function A. Function A has some lines of code, and then x equals function B call. X equals function B, some more lines of code, and then it returns a result. So when function A has a call to function B, it would go over here to function B, and then it would run the code for function B. And let's say function B looks very similar to function A and it also has an x equals, but this time it's assigned to function C. Some more code and return a result. Here, let's say function C is a bit simpler. Let's say function C just returns a value of 1. Okay? So what's going to happen here is when function C returns a value of 1, this value of 1 is plugged back into this function C. And so x is evaluated to function C. Some more code is run, and a result is able to calculate, and this is passed back to function B. Some more code is run again, and it's able to return a result, and we have our result of function A. If we were to put this in box diagram form, it might look something like this. Function A calls function B, calls function C, and then function C returns the value to function B, which returns a value to function A, which allows us to get a result. Okay? So this is how function calls might work in general in a non-recursive case. So one thing I want to point out here is that we have different x's. We have different x's. Okay? Even though this variable here in function A is called x, and this variable here in function B is also called x, these are two different variables. They have their two different spaces in memory, and they hold two different values. Okay? So even though they're both named x, this one belongs to the scope of function A, which is to say it is within function A, and so that's sort of its own little playground. It keeps track of function A keeps track of its own variables, and then function B also has its own separate scope where it keeps track of its own variables. Okay, so we're going to keep this in mind that there's different x's even though they're both called x, because this is going to apply to the recursive case.